Okay, so our next topic is numerical integration. Now this numerical integration is basically used to evaluate the value of definite integral. Okay, we have to calculate integration a to b fx dx. Now we all know that this integration a to b fx dx is nothing but the area under the curve. Suppose if we have curve y equals to f of x and these are the two lines x equals to a and x equals to b, then area under this curve, this area is the value of definite integral, integration a to b fx dx. Now there are a number of ways of evaluating this definite integral using numerical integration technique. So the first one is trapezoidal rule. Now in trapezoidal rule what we do is that suppose if we have this curve y equals to f of x, this line is x equals to a, this line is x equals to b. Now we have to evaluate the area under this curve y equals to fx between these two lines x equals to a and x equals to b. So the first starting point is x equals to a and the last point is x equals to n. Now between these 2 points we divide this entire region by a number of vertical lines, okay, and the distance between each of these two consecutive lines is constant. This distance is h, this distance is h, and similarly the distance between last two lines is also h. So if the first point is a, or this point you can call as x naught, so the second point x1, this will be x naught plus h. Okay, this point is x naught and this distance is h. So this will be x naught plus h. Next point will be x naught plus 2h. Okay, and similarly x3 will be x naught plus 3h and so on. And last one xn, this will be x naught plus nh. So and the corresponding value of y here is when x is x naught, the value of y is y naught. When x is x1, the value of y is y1. Similarly, here the value of y is y2, y3, yn minus 1, and here the value of y is yn. Now, between these 2 points, we approximate the curve by a straight line. Okay, instead of evaluating the area under actual curve, we will find the area under this straight line only. And therefore, this numerical integration will not give us exact value, but approximate value. Similarly, between these 2 points also, we are going to approximate the curve by a straight line. Here also by a straight line, and the last one, this is our curve y equals to f of x. So these 2 points are also approximated by a straight line. Now instead of evaluating the area under actual curve, we are going to find area under these straight lines. Now as you can see that this will become a trapezium. The area of this first trapezium will be half sum of the length of parallel sides. So one side is y naught, another is y1. So y naught plus y1 into h. This will be the area of this first trapezium. Similarly, the area of this second trapezium will be half. One side is y1, other side is y2. So y1 plus y2 into h. The area of this third trapezium, this will be half y2 plus y3 into h. And finally, the area of this last trapezium will be, the curve is y equals to f of x. The area of this last trapezium will be half yn minus 1 plus yn into h. So now we have to calculate the total area under the curve. So this total area will be the sum of area of each of these trapeziums. So if we add all these area, then the value of this definite integral, integration a to b fx dx, this will be area of the first trapezium is, now as you can see, you can take h by 2 common from all these. So you will get h by 2 and then will get y naught. Okay, y1 you can see you will get 2 times. So 2 times y1. Similarly y2 also, y2 is common to both this second and third trapezium. So you will get y2 plus y2, 2 times y2. This will continue up to yn minus 1 plus yn. So this will approximately give us the area between these two lines x equals to a and x equals to b under the curve y equals to f of x. So in trapezoidal rule, here we do linear approximation, meaning that we approximate the curve by a straight line. Okay, and the formula here will be integration a to b fx dx. This will be simply h by 2 y naught plus 2 times y1 plus y2 up to yn minus 1 plus yn. So this is very simple formula. One more important thing that you have to remember is the value of h. This will be given by the formula b minus a by n. Okay, as you can see that xn xn is b and this is x naught plus h. So this means b will be a plus nh. So h will be b minus a by n. So the width of each of these trapezium that can be obtained using this formula, b minus a by n. Okay, so this was the first formula, trapezoidal rule. Here we do linear approximation. There are two other important techniques to evaluate the value of definite integral. The next one is Simpson's 1/3 rule. So in Simpson's 1/3 rule, what we do is that we take 3 points and then we join those 3 points by a quadratic curve. Okay, by a second degree curve, we will join these 2 points. And instead of evaluating the area under actual curve, we will evaluate the area under that parabola, okay, or the quadratic curve. Now you have to remember the formula only. Here the formula for the definite integral will be h by 3, okay, 1/3 rule. So h by 3 y naught plus 4 times y1 plus y3 plus y5 and so on, terms with odd coefficient 1, 3, 5 and so on, plus 2 times y2 plus y4 plus y6 and so on, and finally yn. So this will be the formula to evaluate the value of definite integral using Simpson's 1/3 rule. Okay, h by 3 y naught 4 times terms with odd coefficient plus 2 times terms with even coefficient plus yn. And here we do quadratic approximation. Quadratic approximation means we take 3 points and then we join them by a second degree curve. And the last one is Simpson's 3/8 rule. Simpson's 3/8 rule. So here also you have to remember the formula. The approximation that we are going to do is cubic approximation, meaning that now we will take 4 different points, okay, 4 consecutive points, and then we'll join these 4 points by a cubic curve. Okay, so here the formula for definite integral will be Simpson's 3/8 rule. So this means 3h by 8, okay, y naught plus 3 times y1 plus y2 plus y3 plus, not y3, y1 plus y2, then y4 plus y5 and so on, plus 2 times y3 plus y6 and so on, and the last term will be yn. So these formula you have to remember. Here in 3/8 rule you have y naught plus 3 times 1, 3, 4, 5 plus 2 times terms which are multiple of 3, so 3, 6 and so on, plus yn. So these 3 formula you have to remember. Now we are going to take one problem and we'll see how to apply this concept, how to use this formula. Okay, so our first problem is find the value of this integral 0 to 6 dx by 1 plus x square using these 3 methods: trapezoidal rule, Simpson's 1/3 rule and 3/8 rule. We have to take h as 1. So here our fx is, y is fx, and this is 1 by 1 plus x square. The value of x naught is the first point A, so x naught is 0. Okay, now we have to find the different value of x. So x1 will be x naught plus h. X naught is 0 and it is given that we have to take h as 1. Okay, in some other problem it is possible that number of intervals n will be given. Suppose if n was given, then using this formula we can also calculate h. Okay, here h is directly given, but if n was given, then we have to calculate h using this formula, b minus a by n. So x1 will be x naught plus h. X naught is 0, h is 1, so this will be 1. Similarly x2, this will be x naught plus 2h, so this will be x naught is 0, h is 1, so this will be 2. Similarly x3 will be 3, x4 is 4, x5 is 5 and x6 is 6. Now we have to find the corresponding value of y. So when x is 0, when x is x naught, the value of y will be represented by y naught, and this will be 1 by 1 plus 0 square, because this is the expression for fx. Fx is 1 by 1 plus x square. So when x is 0, the value of y will be 1 by 1 plus 0 square, so this will be 1. Similarly y1, now x1 is 1, so y1 will be 1 by 1 plus 1 square, so this will be 1 by 2.5. Then y2, this will be 1 by 1 plus 2 square, which is 0.2. y3, this will be 1 by 1 plus 3 square, so this will be 0.1. y4 is 1 by 1 plus 4 square, so 1 by 17. y5, this will be 1 by 1 plus 5 square, so 1 by 26. And finally y6, this will be 1 by 1 plus 6 square, so 1 by 37. So these are the different value of y. Okay, if you want to form a table, you can write this in a tabular form. So we can write the value of x and the corresponding value of y. x0, x1. Say here we can write the different value of x and here the corresponding value of y. Okay, so x0 is 0, y0 is 1, x1 is 1, y1 was 1 by 2, so y1 was 0.5, x2 is 2, y2 is 0.2, x3 was 3, y3 was 0.1, x4 was 4, y4 will be 1 by 17, x5 is 5, y5 this will be 1 by 26, and finally x6 this was 6, y6 this will be 1 by 37. So these are the different value of y corresponding to different value of x. Now in Simpson's, first we have to find the value of this integral using trapezoidal rule. So here the value of definite integral will be, the formula was h by 2 y0 plus 2 times y1 plus y2 up to y5 plus y6, right? Because yn is y6, so 2 times y1 up to yn minus 1 plus y6. Now if you substitute these numbers in place of y0, place 1, y1 0.5, y2 0.2 and so on. So if you substitute these numbers, then the value of integral that you are going to get is 1.4108. Okay, you can perform the calculation on your own. You have to substitute these numbers in place of y0, y1 and so on. Then the value of integral that you will get is 1.4108. So this was about trapezoidal rule. Second, we have to calculate using Simpson's 1/3 rule. So here the value of integral will be 1/3 rule means h by 3 y0 plus 4 times terms with odd coefficient. So this means 1, 3 and 5 plus 2 times terms with even coefficient. So y2, y4, y6 is also yn. So this means the coefficient of y6, this will be 1. Okay, so this will be the formula for Simpson's 1/3 rule. y0, remember that in all the three formula the coefficient of y0 and yn is 1. 4 times terms with odd coefficient and then 2 times terms with even coefficient. So if you do the substitution, if you substitute these numbers, then the value of integral that you are going to get is 1.3662. Okay, this will be the value of integral that you will get using Simpson's 1/3 rule. And finally Simpson's 3/8 rule. So in Simpson's 3/8 rule, the formula will be 3/8 rule means 3h by 8. So this integral will be 3h by 8 y0 plus 3 times y1 plus y2, then y3 plus y4 plus y5 plus 2 times terms which are multiple of 3. So this means y3, y6 is also the last term, so this means y3 plus y6. So this will be the formula in Simpson's 3/8 rule. y0 3 times 1 3, then 4 5, okay, then 2 times terms which are multiple of 3, so y3, yn is y6, so this means coefficient of y6 will be 1. Now again if you do the substitution, if you substitute these numbers in place of y0, y1 and so on, then the value of integral that you are going to get is 1.357. So as you can see that these are the values that you will get using numerical method. Also if you want to calculate the exact value, okay, exact value of this integral, then you can see that it is very easy to integrate this. The integral will be tan inverse x and the limit is from 0 to 6. So this will give us tan inverse 6. The value of tan inverse 6 is 1.4056. 1.4056. So as you can see, the value of exact integral is 1.4056, and the value that we are getting using different numerical method technique, trapezoidal rule, Simpson's 1/3 and 3/8 rule, these are very close to the exact value. Exact value is 1.4. Here we are getting 1.41, here 1.36, here 1.357, and so on. So this was all about numerical integration. We'll take one more problem which is from the GATE previous year paper, and we'll see how to apply this formula. Okay, so our next problem is, this problem is based on trapezoidal rule. This was asked in GATE 2014 in mechanical. So the problem is, we have to evaluate the value of this integral, integration -1 to 1 mod x dx using trapezoidal rule, and we have to use 3 intervals. So here the value of n is 3. So this means h will be b minus a by n. B is the upper limit of integration 1, a is the lower limit of integration, number of intervals is 3. So this means h will be 2 by 3. Also here the f of x is simply mod x, right? This is your function f of x. So f of x will be mod x. Now x naught, this will be -1. Y naught, this will be f of x naught. So f of -1, this will be +1, because fx is mod x, so mod of -1 will be +1. Then x1, this will be x naught plus h. X naught is -1, h is 2 by 3. So -1 plus 2 by 3, this will be -1 by 3. Y1, this will be f of x1, so f of -1 by 3, this will be +1 by 3. So y0 is 1, y1 is 1 by 3. Then we have to calculate y2 and y3. For that we will need the value of x2 and x3. So x2 will be x0 plus 2h. x0 is -1 and h is 2 by 3. So 2h will be 4 by 3. So x0 plus 2h, this will be 1 by 3. Or you can also see that -1 by 3 plus 2 by 3, this will be +1 by 3. y2, this will be f of x2. So this will be +1 by 3. And finally x3 is x0 plus 3h. So 1 by 3 plus h. h is 2 by 3, so this will be 1. And y3 will be f of 1. So this is 1. So these are the values of y. y0 is 1, y1 1 by 3, y2 1 by 3, y3 1. So the value of integral using this trapezoidal rule, the formula was h by 2 y0 plus 2 times y1 plus y2 and plus yn, so yn is y3. So this will be the formula. In GATE most of the problems are on trapezoidal rule only, so this is most important formula that you have to remember. So now we have to substitute the values. So in place of h we have to write 2 by 3 and this divided by 2. y0 is 1, 2 times y1 was 1 by 3, y2 is 1 by 3 and y3 will be 1. So this we will get 1 by 3, 1 plus 1 2 plus 2 into 2 by 3. So this will be 4 by 3, 4 into 3 into 2 6 plus 4 10. So this will be finally 10 by 9. Okay. Now we are also going to see graphically that what is the value of exact integral and the value that we are getting using trapezoidal rule and why there is some difference between these two. So if we want to evaluate the exact integral, exact value, so this will be integration -1 to 1 mod x dx. So this we can write as -1 to 0 mod x dx plus integration 0 to 1 mod x dx. So this will be integration -1 to 0. Now we know that mod x is minus x if x is negative. So when x is from -1 to 0, in place of mod x we can write minus x plus integration 0 to 1. Okay, this is the definition of mod x. Mod x is x if x is positive and minus x if x is negative, because if x is negative then minus x will be positive. So -1 to 0, in place of mod x we have minus x because x is from -1 to 0, and plus 0 to 1. Now when x is positive, mod x will be simply x dx. So now this will be integration x square by 2 limit from this will be minus x square by 2, so we are going to change the limit of integration, plus here x square by 2, 0 to 1. Now if you substitute these numbers, you will get 1 by 2 from here, 1 by 2 from here, so this will be 1. So the value of exact integral is 1, and the value that we are getting using trapezoidal rule is 10 by 9. This is, by the way, this is our answer, because the question was we had to find the value of integral using trapezoidal rule. So using trapezoidal rule, we will get 10 by 9. Now I am trying to explain why we are getting a different value in trapezoidal rule compared to the exact value. Exact value of integral will be 1. Using trapezoidal rule, we will get 10 by 9. So if you see the graph of y equals to mod x, the graph of y equals to mod x will be this graph, okay, and we had to evaluate the value of integral from x equals to minus 1 to x equals to plus 1. So basically we had to evaluate the area under this curve. So you can see that we are getting two triangles. The area of each of these triangles will be 1 by 2 and 1 by 2, and the total area will be 1. Now in in trapezoidal rule, we are dividing this into three equal parts. Okay, here the value of x will be minus 1 by 3. Here the value of x will be 1 by 3. Now in trapezoidal rule, we join these points by a straight line, and then we evaluate the area under that straight line. So between these 2 points, let me call this point A, B, C and D. So between these 2 points A and B, the actual curve and the approximated straight line, these two are same. But between B and C, what is happening? That the actual curve is these lines, okay, and we are approximating the curve by a straight line between B and C. And similarly between C and D also, we are getting the same straight line. So between point B and C, the actual curve and the approximated curve, these are different, right? In trapezoidal rule, we are actually evaluating the area under this curve, okay? So this is the extra area that we are getting, the area of this triangle. This is the extra area that we are getting, and you can see that this area will be 10 by 9 is nothing but 1 plus 1 by 9. So exact value is 1, but using trapezoidal rule, we are getting this 1 by 9 extra. So this 1 by 9 is nothing but this area, okay? So this was very simple problem. We had to evaluate the value of this integral using trapezoidal rule. So the correct answer for this question will be 10 by 9, okay? So after this, we are going to talk about numerical solution of ordinary differential equation. Okay, so our last topic from this chapter is numerical solution of ordinary differential equation. Here we have to learn three different techniques. So the first one is Euler's method. So the problem is a differential equation is given, dy by dx equals to some function of xy, and suppose the solution of this differential equation is y equals to some function of x. Okay, this is the solution of this differential equation. So when the value of x is x naught, the value of y is known, okay, and our problem is, okay, this thing is given, when x is x naught, the value of y is y naught. Now our problem is we have to calculate the value of y when x is xn. This thing we have to calculate, and the step size that we have to use, that will be given in the problem. Step size is h. So this we have to do in a number of steps. First we have to calculate x1. x1 will be x naught plus h. We have to find the corresponding value of y. y will be y of x1. We will see how to find the formula for this thing, okay? But for the present moment, you should know that y1 is nothing but value of y when x is x1. Similarly x2, this will be x naught plus 2h. The corresponding value of y will be y2, and similarly if the xn will be x naught plus nh, and the corresponding value of y will be yn. Now ultimately this yn we have to calculate, okay? So problem is a differential equation is given, step size is given. When x is x naught, the value of y is y naught. This thing is given, and we have to calculate the value of y when x is xn. So first we are going to see what should be the formula for this y1. So suppose if this is the graph of y equals to f of x, this is the solution of the given differential equation. When x is x naught, the value of y is y naught. So this height will be y naught, and the coordinate of this point will be x is x naught, y is y naught. Now when x is x1, then we need to calculate the value of y. So this height will be y1, okay? When x is x1, the corresponding point on this curve is this point, so this height will be y1. Now in numerical method, we never calculate the exact solution. We always try to find out the approximate solution. So in this Euler's method, which is very basic method, we draw a tangent line at this point A, okay, and if this point, this is the point where the tangent to A is crossing this vertical line, then we will say that approximately this is the value of y1. Okay, instead of calculating the actual value, we will find only this height and we will say that this value is y1. Now obviously this is not the exact value, but if h is sufficiently small, the distance between these 2 points is h. So if h is very small, then these two heights, this approximated height y1 and the actual height y1, these two will be same when h is very small. So now our job is, we have to find the expression for this y1. So y1 will be, as you can see from this graph, y1 will be nothing but y0 plus this height bc. Okay, this height will be y0. We are drawing a line parallel to this x-axis. So if this point is b and this point is c, then this height bc plus y0, this will be equal to y1. Okay, so now our job is, we have to find the expression for this bc. So if this angle is theta, okay, then this tan theta will be bc by ab, right? Tan theta will be perpendicular by base. Perpendicular is bc, base is this ab. Now we know that tan theta is nothing but slope of tangent. So slope of tangent, this will mean dy by dx at this point A, and this will be equal to BC by AB. AB is nothing but h. So from here you can write that this BC will be h into dy by dx at point A. Now the expression for dy by dx is f of xy. Okay, since this y is the solution of this differential equation, so dy by dx has to be equal to f of xy. So this means dy by dx at point A, this will be f of x0 y0. So this will be the expression for BC, h into the value of first derivative at point A. So from here we can get the expression for y1. y1 will be y0 plus h into f of x0 y0. So using this formula you have to calculate y1. Once you have calculated y1, then formula for y2 will be y1 plus h into f of x1 y1. Okay, and in this way we have to calculate the next value y3. For y3 the formula should be, y3 will be y2 plus h into f of x2 y2, and the general formula will be yn is yn minus 1 plus h into f of x minus xn minus 1 yn minus 1. So this will be the general iterative formula. By substituting different value of n, you will get these values y1, y2, y3 up to yn. So this was the basic idea behind this Euler's method. Now with the help of one example, we will see how to solve the problem based on Euler's method. Okay, so our first problem on Euler's method is, this differential equation is given dy by dx minus y equals to x. When x is 0, the value of y is 0. Okay. Now the problem is, using Euler's method with a step size 0.1, we have to calculate y of 0.3. So first of all, we have to write the differential equation in a standard form. So dy by dx will be x plus y, and this x plus y is nothing but f of xy. f of xy is x plus y. When x is 0, this we can call as x0. So when x0 is 0, the value of y is y0 and y0 is also 0. Okay, when x is 0, the value of y is 0. The step size that is given to us is, step size h is 0.1. So now first we have to calculate the value of x1. x1 will be x0 plus h. x0 is 0, h is 0.1, so this will be 0.1. y1, this will be y of x1. This we need to calculate. We'll see how to calculate this. Then x2, this will be x0 plus 2h. So this is 0.2. y2 will be y of x2. This again we need to calculate. And finally x3, this will be x0 plus 3h. So this is 0.3. y3, this will be y of x3. Now ultimately this y of x3, this we have to calculate. Okay, we have to calculate y of 0.3. x3 is nothing but 0.3. So in 3 stages we have to find the value of y of x3. So first we are going to calculate y1. The formula for y1 was y0 plus h into f of x0 y0. y0 is 0, h is 0.1. f of x0 y0, this will be x0 plus y0 x naught is 0, y naught is 0. So this means because f of xy is x plus y. Okay, so f of x naught y naught, this will be x naught plus y naught. X naught is 0, y naught is 0. So this will be 0 plus 0. So finally y1 will be 0. Okay, so y1 is 0. Now we need to calculate y2. So y2 will be y1 plus h into f of x1 y1. y1 is 0, h is 0.1. f of x1 y1, this will be x1 plus y1. x1 is 0.1, y1 is 0. So this will be x1 is 0.1, y1 0. If we multiply these two, we'll get 0.01. So this will be the value of y2. y2 will be 0.01. Finally, we need to calculate y3. So y3 will be y2 plus h into f of x2 y2. y2 is, we have calculated y2, y2 is 0.01. So in place of y2, we have to place 0.01. h will be 0.1. f of x2 y2, so this will be x2 plus y2. x2 is 0.2, y2 is 0.01. So this will be 0.2 plus 0.01. So 0.01 plus, this will be 0.21, so 0.021. Now if you add these two, you will get 0.031. So this will be the value of y3. y3 we had to calculate. The value of y3 is 0.031. So this will be the answer. We had to calculate the value of y when x is 0.3. So the value of y when x is 0.3 is 0.031. So after this, we'll talk about the other two methods, RK2 method and RK4 method. Okay, so our next method is modified Euler's method or RK2 method. RK2 method means Runge-Kutta method of second order. So here also we have the same problem. A differential equation is given, dy by dx equals to some function of xy. The solution of this differential equation is this y equals to some function of x. When x is x naught, the value of y is y naught. Now when x is x1, then we have to calculate the value of y. Okay, y will be y1. y1 is nothing but y of x1. So this we need to calculate. And in the problem, the step size will be given. The step size that is given to us is h. So here in modified Euler's method, the formula to calculate y1, this will be y naught plus k. Okay, this will be the formula to find y1. y1 will be y naught plus k. And this k is nothing but half of k1 plus k2. Okay. Now the formula to calculate k1 will be, k1 is h into f of x naught y naught. Okay, this is same as the Euler's method. In Euler's method also we had the formula for y1 was y naught plus h into this term. So this term is represented by k1, and k2, this is h into, the formula to calculate k2, this will be h into f of x naught plus h, y naught plus k1, where in place of k1 you have to use this k1. So first we need to calculate k1, this will be h into f of x naught y naught. Then we need to calculate k2, k2 will be h into f of x naught plus h, y naught plus k1. Then you have to take the arithmetic mean of these two. Okay, arithmetic mean of these two means k1 plus k2 by 2. So then you have to calculate this k, and once you have calculated this k, y1 will be nothing but y naught plus k. So now with the help of one problem, we'll see how to calculate these things. So this question was asked in GATE 2013. The problem is this differential equation is given. Differential equation is dy by dx plus 2xy square equals to 0. So this we can write in a standard form as dy by dx, this equals to minus 2xy square, and this minus 2xy square is nothing but f of xy. f of xy is minus 2xy square. Now y0 is 1, so this means x naught is 0 and y naught is 1. Okay, y naught is nothing but f of x naught. So x naught is 0, and when x is 0, the value of y is 1. Now the question is using RK2 method. RK2 method, you can also call this as modified Euler's method, or sometimes this is also called predictor character method. So RK2 method, modified Euler's method, or predictor character method, all these three are same. So using this RK2 method and taking a step size as 0.2, h we have to take as 0.2, The value of y after first step will be, so we have to calculate y1. Y1 will be y0 plus k. This k will be half of k1 plus k2. So first we need to calculate these k1, k2, then we'll calculate k, and then we'll calculate the value of y1. So our k1 will be h into f of x0 y0. This will be the value of k1. So in place of h we have 0.2, and in place of f of x0 y0, so this will be simply f of x0 is 0, y0 is 1. So f of 0 comma 1. So this will be, now f of xy is minus 2xy square. Now in place of x, if you substitute 0, then this term will become 0. So this means the value of k1 is 0. Now we need to calculate k2. So for k2 the formula will be, k2 is h into f of x0 plus h, y0 plus k1. So this will be, in place of h we have 0.2 f of x0 plus h. x0 is 0, h is 0.2, so this will be simply f of 0.2, and here y0 plus k1, y0 is 1 and k1 is 0. So here we'll get 1. So this will be f of x0 plus h, y0 plus k1. So finally we'll get 0.2. f of xy is given by this formula, minus 2xy square. So this will be minus 2x y square. Now if you do the calculation, you will find that this will be minus 0.08. You have 2 into 2 into 2, so this will be 8. So we'll get minus 0.08. This will be the value of k2. Now once you have calculated k1 and k2, the value of k will be half of k1 plus k2. So this will be half of k1 is 0, k2 is minus 0.08. So this will be minus 0.04. So in place of k we have obtained this minus 0.04. So finally our y1 will be, y0 was 1 and k is minus 0.04. So this will be 1 minus 0.04, which is 0.96. So the correct answer for this question is option D, 0.96. So this was all about modified Euler's method or RK2 method. Now we have to learn one more technique for numerical solution of ordinary differential equation, that will be RK4 method. So our last method is Runge-Kutta method of fourth order or RK4 method. So here also we have the same problem. The differential equation that is given to us is dy by dx, some function of xy. When x is x0, the value of y is y0. When x is x1, then we need to calculate the value of y. So say this value is y1. So this y1 we have to calculate, and the step size that we have to use, that will be given in the problem. So step size is h. Now here the value of y1 will be y0 plus k. Okay, the value of y1, this will be given by the formula y0 plus k, and the formula to calculate k, this will be 1/6 of k1 plus 2k2 plus 2k3 plus k4. Okay, why we are dividing by 6? Because we have 2 and 2 here, one hidden coefficient here and one here. So the formula for k will be 1/6 of k1 plus 2k2 plus 2k3 plus k4. Once you have calculated k, then the value of y1 will be y0 plus k. Now the formula for k1, k2, k3, k4 are, k1 is h into f of x0 y0. Okay, this is similar to Euler's method and RK2 method. K1 will be h into f of x0 y0. Then we have to calculate k2. K2 will be h into f of x0 plus h by 2, y0 plus k1 by 2. Remember that this k1 will be this k1. From here you have to substitute the value of k1 here. So k2 will be h into f of x0 plus h by 2, y0 plus k1 by 2. Then we need to calculate k3. K3 will be h into f of x0 plus h by 2, y0 plus k2 by 2. Okay, once you have calculated k2, then you have to substitute the value of k2 here to get the value of k3. K3 will be h into f of x0 plus h by 2, y0 plus k2 by 2. And finally you have to calculate k4. So k4 will be h into f of x0 plus h, y0 plus k3, This K3 will be substituted from here. So these are the formula to calculate K1, K2, K3, K4. This you have to remember. K1 is same as the other two methods, Euler's method or RK2 method. For K2 you have h by 2 here, K1 by 2 here. For K3 also you have h by 2, K2 by 2. And for K4 you have x0 plus h, y0 plus K3. Once you have calculated these four values, then you need to find K, and then your value of y1 will be y0 plus K. Now with the help of one problem, we'll see how to apply this formula. So the differential equation that is given to us is dy by dx 1 plus y square. So this means f of xy is 1 plus y square. Then y0 is 0. So this means x0 is 0 and y0 is 0. Now using RK4 method with a step size 0.2. So h that we have to use is 0.2. So using this as step size, we have to calculate the value of y of 0.2. This y of 0.2 is nothing but y1. Okay, so this y1 we have to calculate. Now y1 will be y0 plus k. The value of k will be 1 by 6 k1 plus 2k2 plus 2k3 plus k4. So first we need to calculate these values k1, k2, k3, k4. Then we will calculate k, and then our y1 will be y0 plus k. So now we are going to calculate each one of these values. So k1 will be h into f of x0 y0. The value of h that we have to use is 0.2. x0 is 0 and y0 is 0. So this will be f of x0 0, y0 0. So 0.2. Now f of xy is 1 plus y square. So this will be 1 plus 0 square. After calculation we'll get 0.2. So this is the value of k1, 0.2. Now we need to calculate k2. So k2 will be h into f of x0 plus h by 2, y0 plus k1 by 2. So now h will be, the value of h is 0.2, f of x0 plus h by 2, x0 is 0, h is 0.2, so we'll get 0.1 here. And y0 plus k1 by 2, y0 is 0 and k1 is 0.2, so this will be 0.1 k1 by 2. So this will be 0.2 1 plus y square. Dy by dx is 1 plus y square, so 1 plus 0.1 square. So this will be this will get as 1.01 multiplied by 0.2, so this will be 0.202. Okay, so k1 is 0.2, then k2 is 0.202. Now we need to calculate k3. So k3 will be h into f of x0 plus h by 2, y0 plus k2 by 2. So this will be 0.2, x0 plus h by 2, this will be 0.1, y0 plus k2 by 2, so 0.101, this will be 0.2 into 1 plus 0.101 square. Now if you perform the calculation, then you will get this number 0.202. Okay, so this will be the value of k3, 0.202. Now finally we need to calculate k4. K4 will be h into f of x0 plus h, y0 plus k3. So this will be 0.2 f of x0 plus h, x0 is 0, h is 0.2, so this will be 0.2 here, and y0 plus k3. In place of k3 we have 0.202, so this will be 0.2, 1 plus 0.202 square, so this will be 0.208. So this will be the value of k4. Now once we have calculated these four numbers k1, k2, k3, k4, now we need to calculate k using this formula. So this will be 1 by 6, k1 is 0.2, 2 times k2, k2 is 0.202, then 2 times k3, so this will be 0.202, and finally k4, so 0.208. So now from here you have to calculate the value of k. So the value of k that you are going to get is 0.2027. This will be the value. You can perform the calculation on your own. So once you do the calculation, you will find that the value of k will be 0.2027. So the value of y1, this will be y0 plus k. y0 is 0 and k is 0.2027. So finally the value of y of 0.2 this will be 0.2027. So this will be the answer to the given problem. So this was the last method for solving any ordinary differential equation, RK4 method, and this was the last topic from this chapter.